Assalamualaikum everyone, I am Sumayya Shimu. Today I would like to explain how backpropagation works in deep learning with a special focus on backward pass and the chain rule. First, we need to know what backpropagation is. Backpropagation is a learning algorithm used in deep learning. It updates the parameter to reduce the loss. So, what are the parameters? The parameters are basically weights and biases that we use in the forward pass. It also uses the make use of the chain rule. Chain rule is basically a mathematical engine that we use to make the backpropagation use easy. It learning happens here in the backward pass. To understand the concept more clearly, we will make use of the equation E is equals to A plus B multiplied by C. So why this equation? Although this equation looks simple, it behaves like a small neural network and clearly demonstrates how gradients are calculated. Let me briefly mention the forward pass. In the forward pass, we only compute the output. We break the equation into two steps. So our equation was E equal A plus B multiplied by C. In the first step, it will be D equal A plus B. So the overall equation becomes E equal D multiplied by C. That's it. This is the forward pass step. So here comes the backward pass, the most important part. In the deep learning, learning happens only when we know how much each input contributes to the final output. For that, we calculate the gradient. So during the backward pass, our goal is to find this is derivatives. So what are these is derivatives? These is derivatives are how much the output changes with respect to the inputs. So here are the inputs are A, B, and C, and the output final output is the E that we have already seen in the previous step, that is in the forward pass. For better understanding the topic, let's draw the computation graph. If we draw the computation graph, I think we will understand the topic better. So our equation was E equal A plus B multiplied by C. After simplifying, the equation become D multiplied by C. So let's draw the equation. First, draw this part. Uh, First, let's take the input, that is AB. Then we will take the plus sign, and then this becomes D, then another input, that is C, and they both get multiplied, and the final output become E. Now the gradient are calculated in the backward pass, that is in this backward pass. So we first need to find the partial derivatives of these parts. So partial derivatives of E with respect to E became 1. Now we need to find out how much E changes with respect to D. If we calculate this, so the partial derivatives will be the partial derivatives of E with respect to D. That is partial derivatives of D, and here as we know, D is A plus B. The value of E here is D multiplied by C, so the derivatives will become here C. Then if we come to this part, then we need to determine the partial derivatives of D with respect to A. So partial derivatives of D with respect of A, here we need to determine the value of this part. Here if we write this, here the value of D is A plus B. A plus B. So here it is, as we know, it is 1. Now comes to the final part, that is the chain rule. We need to determine how much the output here, output E changes with respect to the input A. So if we compute this, so the final output becomes dt of E, partial derivatives with respect to A. Here the back propagation, we need to multiply all of this, like we need to multiply this one with this part. So multiply of this with respect to this one. So here the result is C multiplied by 1, that is C. we need to compute this type of this rule for the input B and the input C. Here the part is same. Here the rule is same for all. In real deep learning models, the equations are more complex and include weights, biases, activation functions, and loss functions. However, the core logic remains the same. Backpropagation is simply a related application of the chain rule during the backward pass. To conclude, the forward pass computes the output, but the backward pass computes how model learns. Uh, so this is all about my presentation. Thank you all.